So here's a part that we'll just do a quick little turning operations on it, and we'll mill some of these features as well. I'm going to create a brand new file from this. So this will be on my master model. I'm creating a brand new file off of this, and I'm actually going to put this on a machine that we've got. We've got an Integrax i200 here that I'll put on. I'll put this part on that machine. So this will give you a little bit of insight into turning, mill turn, and simulation. This part happens to have dual spindles on it, so it actually brings in the part for me twice. I'll turn the model of the machine on here. So here's the machine. So we've got a main spindle and we've got a sub spindle. All right, again, I'm going to start with some assembly constraints and line everything up, position everything first. All right, so we'll start with assembly constraints. I always like to fix that machine first. I want the parts to move them to the machine, not the machine to the parts. So from here, we got this one. I'm going to do an align lock where I can just grab the center lines of the parts, and it's going to go and lock those up. We'll do a distance. I'll move this out just outside of the chuck a little bit there. All right, I'm going to go ahead and constrain this one up over here as well. So we'll do, let me do a parallel here as well. We'll do a parallel. I'll make this surface parallel to the other part here, and I'll do a center line on it. So we just like to position it this way. I mean, we could certainly grab the part and just move it and lock it down too. But I like to do some of these where it's really fine tuning exactly what you want. So I'm going to do this one as well. I'll make a distance constraint and move it out to about 58 inches should work there. So now we're all locked into place here as well. Next thing I'm going to do again is that wave geometry linker. We're going to make those associative copies of these parts. That part and this part. And the next thing with this simulation that I want to do, as this spindle is turning, I want the part to actually turn with it when I run the simulation. So I'm actually going to add that into the kinematics here for the part. I'm just going to define the part really quickly, as well as on the sub spindle. I just have to define that part. All right. So now we are going to define all of our geometry. We'll take a look at these items. So this is for, kind of like a multi-channel. This one isn't necessarily multi-channel, but it's a dual spindle. So we have a couple of parts that we're going to define here. So I'm going to start with my first part here, and I'm going to specify our blank in here using just a bounding cylinder on this one. Okay, I'm going to change my diameter of my raw stock here to about 6 inches. I'll just make it about 6 inches long as well. And we'll just make 50 thousandths on the front of it, so we're chucking on a little bit of that material on the back side here. Again, if you want to do the check geometry, we'll specify that chuck as check geometry there. And for turning, what we have is what we call a, I'm going to hide that part there. What we have is what we call a spun outline. So I'm going to set my MCS for this spindle. But what we have is a spun outline, because as these hexes are turning, obviously we want to know what we want to turn, what diameter we want to turn when it's spinning. So that's what it gives us as our spun outline. So if I look at the spun outline, that's what I actually want to create as it's turning. We'll come back and mill the milled features later. All right, so that's our spun outline as well as our spun outline for our blank is up here. So we'll create a couple of operations to turn this part. I'm going to start with a facing operation. And I've got a number of tools. This simulation already had some tools built in it. I've got a OD neutral tool that we'll use for that one. And we'll just rough it with the lathe. We'll do a lathe rough and just generate that one. So there's a facing operation, and it shows, the yellow is what the IPW blank was, and the green is what it just faced away. All right, I'm going to go and throw a couple more operations on here, and then we'll simulate the whole thing. So let me do another operation called rough turn OD. So we're going to just rough the outside of the part. And here, what I want to do is I want to use a trim plane. It's going to try to cut all the way through there. We want it to make sure that we stop where we want it to stop. Well, the check geometry can assist on that too, but we can use this tool. We want to cut through, and we just want to stop it right around here. I want to stop it around that spot, so we can do an axial trim plane or a radial trim plane using that, and we can generate it. And you see, it's just going to stop there, short of those jaws. So that's our roughing operation. Just going to do some simple roughing, and in fact, I could take this a step further and go into this profiling. And I could just add additional profiling. That's just going to take it right to a finished size now. That just went ahead and finished it. It essentially took, if I were to create another operation after that and do a finished turn OD, it essentially just grabbed that and put it right into that operation for us. If I were to look at that now and verify this, I'll just run it through a quick verification this way. This is not the machine simulation. This is just a toolpath verification here. So it's just going to rough it down, then it's going to come back through and do a final finished pass like that. All right, so now we can go right into some of our milling on this. So I want to mill this pocket first, for example. So we're going to create another operation, and I'll switch down to our planar milling operations, and we're going to use that floor and wall that we looked at before. I think I can fit a half inch. Let's see, diameter 600. Yeah, a half inch end mill I can use to cut this. So I'll scroll through my tools and find a half inch end mill here. And set your variables for what you want to cut, and we're going to just tell it the floor of that. We're going to specify that floor. It's going off of this MCS on the front of the part, and we can just simply generate that. So that's going to come in, and once we run the simulation, it's going to know to tilt that up 90 degrees and mill from there. The next operation I want to do, I want to cut this hex on the front, and I'm going to show you a couple different ways to how we can cut that. But let's start with creating an operation. We're going to do I'm going to switch back over to that Z-level profile, and we'll specify some geometry. I'm going to specify some cut area, and again, I like these face rules. I'm going to switch to tangent faces and grab one face because they've got those corner radiuses. All of them are tangent, so I can quickly grab those, and I'll just generate that. All right, so we can cut that. If you want to take it in multiple depths, we could certainly change it to taking, an 1/8 inch per pass if you'd like to take it an 1/8 inch or 100 thousandths, 1/4 inch, whatever you want to do. I'll change it to 300 thousandths on this in this case. So what that's going to do is that's going to take that tool and run it around the part. Another solution, I'm just going to copy and paste this, and I'll show you another solution that we can do inside the operation. We can make it more of a polar mode by using user-defined events, and I can make this a polar event so that the C-axis is what rotates for the cutter. And I'll just go ahead and regenerate that. The toolpath will look exactly the same. Once we verify this, once we run it on the simulation, you'll see the difference there. I also want to drill these holes. So let me see what diameter these are. They're 1/4 inch diameter. I don't know if I've got a 1/4 inch tool, but I could add that in, but I'll just find something close. I'll switch to a drilling operation, and we'll find a 1/4 inch. I don't think I have a drill though. Yeah, so here's a 218 drill. which is good because I'd like to show you anyways how we can look at that preview of these drills. So it's previewing what it's going to drill. It's not just previewing in pink the hole, it's previewing what it's going to actually remove. So it's a little smaller because that drill is a little smaller. All right, and then we're going to just work our way around and select all these holes. My machine's in the way. I'm going to go ahead and just hide it away for a second. And we'll just work our way right around this, selecting all these holes. 5, 6. So we've got all 6 holes there. And we'll just generate that one. So there's our holes generated. And it'd be simple enough if you decide that, I'll turn our machine back on. If you decided that something's out of order a little bit, you can grab that drilling operation and you can move it up and reorder things pretty quickly. It'll let you know that there may be some things with the IPW that it's going to have to update and redo some things. You just have to regenerate toolpaths then. So that's the toolpaths for the front. Let's take a look. We'll just go ahead and run this through a simulation here. Let's see what we get. We'll set up, we'll show some material removal. I can set some simulation settings. We can make these increment based, font. We can make this translucent as well. If we want to see through it a little bit, we can see our part in there now. I'll turn our spun outline off for now too. So let's go ahead and run this through and see what we get out of our simulation here. So we've got the tool changes in there, and then you'll see all the spun kinematics start up, and you'll see the material removal. Okay, everything's stopping short. There's our next tool change to our milling. You can see everything spinning up for it, and then it mills it out. Here's our drilling. And then the next one are the Z-level profiles, where one of them is going to be polar, the first one is not. So the upper head here is actually moving around the part, as opposed to the second operation where the part is going to rotate. So this one, the part is actually just rotating for using a polar operation here. All right, and then we're doing a part transfer, and it's going to move that IPW over to the second side. I've got those set as UDEs in here that I've already populated, and it just moves that right over to that sub spindle. And now we can change our facing operation. We can create a new facing operation on this side of that sub spindle. So let's go ahead and do that. We'll define our sub spindle workpiece. We're going to specify that part and that blank, the raw stock. And in this case, instead of geometry or an offset outline bounding cylinder, we're going to use the IPW. We're going to use that in-process workpiece of this main part right here. All right, we'll update that, and that's going to give us a starting point for that IPW being the blank here. So there's in pink is what we're specified as our stock now. All right, and we've got our MCS set to the face of the part there. Our spun outline is showing up here, and you can see the blank definition from where the face OD, the OD roughing stopped short. So now we just create a new operation in our sub spindle using, we'll just do a simple facing operation. We'll grab our CNMG tool again. We'll do the sub, and we'll just go right to a lathe finish. And now I just have to define, in the tool axis, I'm going to set to, instead of that tool being on a 45 degree, I'm going to move that over to a 135 instead. And we can generate that. So we can see that tool is moving in this direction now. Okay, so if we'd like to see the entire thing simulated once again, we could do that. So we'll grab the parent and simulate the entire machine. We'll speed it up a little bit here. We've seen this part of it already. Oops. All right, and then we'll see the part transfer. Changes tools and cuts the other side. So that's it for the mill turn.